In 2021, life as we knew it was set to change. A series of visionary keynotes revealed a virtual revolution that was supposed to change everything.
Starting today, our company is now Meta.
After Facebook changed their name to Meta in 2021, digital worlds like this experienced a land boom.
Big tech, big brands, big ambitions. People and companies are pouring hundreds of millions of dollars into the vision of the Metaverse.
Technology companies presented a seismic shift to our very existence.
Other companies like Microsoft, Apple, Google, and Valve are also looking to create tools for work and communication.
A world where we'd play, socialize, and exist entirely through virtual reality headsets.
Several major tech companies are dishing out billions of dollars in order to build our very own virtual reality future.
The Metaverse. Tech giants were rebranded, billions were poured in, and the hype was unstoppable. But years later, evidence of this new digital era is hard to find. Was it all just another overhyped tech dream?
98% of those projects are totally dead today. The other 2% of them have lost, 95% of their market cap.
If you asked most people, the answer would be simple. VR is dead. But what if we've been asking the wrong question? In this film, we go around the world, beyond the hype, and behind closed doors to meet the people who have already embraced immersive technology. Not as a futuristic fantasy, but as a solution to solve real-world challenges. Whilst the headlines faded, it seems VR didn't actually disappear. It got to work. In California, Honda's design team are leaders in the use of XR for automotive design, transitioning from the use of clay to virtual models for a more efficient and sustainable design process.
We started our XR journey about 10 years ago. At the time, we were just experimenting, trying to understand the capabilities of that technology. And the direct application to automotive was not very clear at the time, but later on, we realized the potential and started applying it on a regular basis to reduce our reliance, especially on physical mock-ups that are expensive and time-consuming to create. We use XR early in the design process to have an understanding of size and proportion, especially for exterior. And for interior, it gives us the ability to look at a lot of details from the positioning of content to materials and finishes, and try to give the designers a clear picture of what it is that we're going to build.
On the other side of the US, architects at KPF's New York office are doing the same on a larger scale. No more static blueprints or guesswork. XR allows them to experience their designs before they exist, shaping the future of cities before the first brick is laid.
So what we're doing here is we're taking the projects that are currently unbuilt, that we're still in schematic design phase, and we're visualizing them in VR. So instead of us just looking at a 2D screen or a monitor, we're able to take those, put it in a VR experience, and have the design team and the clients visualize the project before construction. Once people put on the headset and they understand that this is actually your project, it's a one-to-one, and that you could potentially save millions of dollars in mistakes or conflicts because you're detecting them early on. That's huge. We want to minimize any on-site issues. So someone's able to put on the headset and realize that maybe the proportions don't feel right, or, oh, I expected it to look like this, but it doesn't look this way. That's huge. That's the biggest point for us using VR. It's really to get everyone comfortable with the design and help pick up on any issues.
This is the interior bug. We have 2 PCs in the front. We have monitors to kind of see what I'm seeing wearing a headset, and the base volume of the model, and a steering wheel for the touch point areas. You can overlay any design with this. this design, we really wanted to capture this driver-oriented feel and very clean, minimal styling, but wanted to capture this very forward gesture, which you can see from the door lining. And we also try to mimic that gesture through the console. And having this driver-oriented graphic definitely helps the overall feel of the car to feel more performance-driven. We never actually made any prototype model. We only used this XR technology to confirm the final design.
Collaboration was very helpful during COVID. We had some stringent travel restrictions, as you know, so none of our executives could travel to the US. So we started using collaboration methods through VR and XR to be able to have people from multiple teams joining and looking at the same thing from Japan, Ohio, LA. That was very critical.
Most of our projects, we're working with another office. So we're all looking at the same data, the same information. So, the New York team could be looking at something that the London team's working on. So we've got that collaboration between our offices. So to be able to put on the headset and for the whole team to kind of walk through their project has been super effective.
But VR isn't just an ideal tool for creation for the real world. It's also about preparation for it. While the world debated the future of VR, the military has been using it to train for the real world. In Florida, defense companies like Cole Engineering and Bohemia Interactive are building training systems that allow military personnel to operate planes, drones, helicopters, and ground vehicles safely, repeatedly, and with absolute precision.
4 years ago, our solution was most likely going to be an optical see-through because it was the only one that could meet all of our requirements for seeing and your legs and everything, your hands and the displays in the cockpit. And thus now we use mixed reality. We can put the virtual environment around them and use the cameras to inset what they would see inside the cockpits. So as John looks, he's flying around here. As he looks through, he scans his cockpit as he's going along, and you can see that he looks inside. The instrument panel's coming through in the mixed reality. You can see he's pushing with his finger there. He's pushing some buttons, which he's doing in the cockpit, and it's showing up in his headset. So when he looks up, now he's looking out the world at an area somewhere in Texas. So you can see he has his chin windows and his side windows, so he can look out through the bottom of the aircraft and see what's going on. That's something if you tried to do with normal displays of some sort, you got a huge dome that you're sitting up high in or something like that to be able to do that. With an HMD, it's just natural. Plus you get the depth perception out the sides. So as you look at the cockpit here, you can see in the picture, he's got all the sill lines and the masks and the framing of the aircraft with the windows, whereas you're sitting here, none of that exists, right? So, but that gives you, so you have all the appropriate blockages in your line of sight and those sorts of things that you would be hard. You'd have to replicate all of that with a display system in the actual cockpit, which makes it really hard to reconfigure, right? If we switch to a different aircraft, all those things are just done in a mask in the image generator, and it just works.
There's obviously a lot of these in the room, and these are set up in cases, so they're portable, I assume?
Yes, they're designed to go to what they call point of need, which is a conditioned environment anywhere you want to put them. The pilots are taught to have muscle memory of how to fly the aircraft, right? It's because they're doing a lot of tasks. The physical controls actually have a huge number of buttons on them, so they have to be able to do that without looking. So the control fidelity is very important. Again, these are collective trainers, but the goal is to keep their workload the same as they would have in the real aircraft versus having a whole bunch of just touch screens that they got to do tasks and do things not the way they would do it in a real aircraft.
What we're simulating here is an ACV, or amphibious combat vehicle. What they're usually used for is amphibious operations. So for example, the Marine Corps trying to take over a beach, they'll send a bunch of these specific vehicles towards the shore. This is a training problem they've been trying to solve for about 40 years, as this is one of the most dangerous jobs in the Marine Corps, because if he makes a mistake, he panics, and he turns his vehicle basically 90 degrees to the left or right, and then he's not going towards the shore, that next wave can hit him and then turn him over, deadlining his vehicle, but most importantly, taking out the entire crew. Just like with flight sims, it's important to get that muscle memory. In this case, this is a prototype, but in a production system, the levers and knobs will be in the exact same place, and the exact same configuration.
So it's kind of the same thing. He's seeing everything here, the physical cockpit controls, right, and then everything outside of that is all simulated.
And the beauty of our simulation is that if he turns his head around right now, what he'll see is he'll see the entire crew of AI behind him in his vehicle that he'd be working with.
So what are the big advantages you're finding with your customer base as using the headset over using monitors or projectors or some other display device?
So the biggest advantage is normally with dome systems, like yes, you can have it all around you, but like the amount of overhead or on just space alone, let alone cost, it's not feasible to keep moving forward with that when we have head-mounted devices that by putting it on, it's essentially a 360 dome on your head.
So what is this solution that you're showing us here now?
So this is what we're calling the sand table. The simplest way to put this is, as a platoon sergeant in, running a platoon, if we were to go on patrol, historically, I would literally go out into the dirt, I would draw a square of the area that we're gonna be patrolling. I try to recreate that route the same way as it would be in the real world, right? Now, this is obviously much better because now we're talking about, I'm looking at the real terrain. This could be a digital twin of the world if I've recently gotten a drone scan, for example. I could actually have my platoon running through this exact scenario before we even exit the wire or like the perimeter of my forward operating base so that they already know where do they need to be, what does it look like, what are the ranges, because we have, bullet velocity and trajectory and such that matches very close to real world weapons. You have an entire staff dedicated to managing small little parts of the fight, be it your communications plan, where is your logistics coming from, so on and so forth. And so I can have them all with headsets looking at the battle and discussing those points and making sure that we're taking every detail into account so that we can make sure as many of our Marines or soldiers or whatever our military members are, make it home safely.
Many promotions at the time focused on the metaverse as a place to have fun. Virtual volleyball on the beach or an awkward game of table tennis. But what if it was meant for more than that? What if it could be used to save lives? Just outside of Brisbane, the Royal Australian Air Force is using XR to prepare their aeromedical teams for high-pressure rescue operations. By blending virtual and real-world training, they're able to rehearse emergency procedures in environments that feel real, but carry none of the risk.
Blueroom is a technology that came out of the Australian Defence Innovation Hub. It's similar to the US's DARPA program. It's a capability that solves a problem of accessing very hard to reach environments such as airframes and combat zones, where you also require to practice physical skills with real world objects to train. We'd explored virtual reality a lot in the past. We'd explored using all the other VR headsets on the market, and VR has its place and it solves a problem for many different use cases. But in medical training, we struggle to see it solving the problem where we require the use of fine motor skills, where I need to take out an intravenous cannula and insert that cannula, or perform an airway skill, inserting an airway adjunct, and using my own hands. And virtual reality, you cannot replicate that with remotes. So Blueroom was a way that we could evolve beyond that and bring in real-world equipment and real-world skills into synthetic environments for training.
Do you want me to take over?
Yeah, if you take over here, I'll stick in a cannula in the back of his hand, because that one looks like it's tissued a bit. So our unit is involved directly with training every single person that joins the Air Force through health. So doctors, nurses, medics, environmental health, all aspects of health. We do their initial training and convert their civilian skills across into military settings. So that could be aeromedical or it could be in a field hospital, just getting them ready to be able to be deployed into either a combatant or a non-combatant operational sort of area. We're able to put people immersively on board a C-17, C-130 aircraft. So when I first put the goggles on, I understood exactly at that time how this could be utilised and the importance of how it could be used in training. When I put it on, I wasn't simply just looking at a C-130, I was actually standing on the back of the C-130. And when we also factored in the haptic floors, the sound, and even the fact the room was as cold as the aircraft, it put me on board the aircraft. So my mindset immediately said, you're on board the aircraft, treat your patient.
You put on a headset and you see an actual scene that you would see out in exercise and operation, but it's all contained within a room. And that way it cuts down, it makes it a lot easier to learn. It's not as expensive to actually go out on aircraft, take aircraft out, do all these difficult to organise things. You can organise it all within a single room and simulate training environments of all sorts.
So being able to replay, in effect, that mission that we've already done means that we can actually look at how we did it, identify the mistakes we've done or identify points for improvement, do it again and do it again and do it again until it becomes part of our muscle memory, and we can just go in and we know that's what we'll do in the next time that situation is faced. We're preparing people for ultimately in the Defence Force to go to war. So from that aspect, we want to make sure that the people have the skills required. So using products such as Varjo with the Blueroom, able to get our people into high fidelity, high realistic training, enables us to ensure that when they are confronted with those situations for real for the first time, that they aren't finding themselves stuck. They're able to just go, okay, I've done this before, I remember what it's like, and be able to dive straight in and deliver the outcomes that we require.
Not every profession allows for hands-on practice. Some environments are simply too dangerous, too expensive, or too complex for traditional training. A cargo ship the size of a city block can't just be used for practice runs. The cost, the logistics, and the risk make real-world training nearly impossible. At Force Technologies, XR is solving this problem. Ship captains are now able to train in ultra-realistic virtual environments, navigating treacherous waters, docking massive vessels, and responding to emergencies, all without ever leaving land. While the Metaverse was imagined as a limitless playground with infinite space, for some industries like these, XR has actually proven a powerful tool for shrinking real-world operations.
Force Technology is an international technology and consultancy firm. We employ roughly 1,100 employees. And the facility that we are in right now is our main maritime hub. So we basically in our center here, we have 9 simulators and they range from big full mission simulators. We are also currently deploying a lot of VR headset. So really where I see the biggest benefit for using the XR technology, one of the big use cases I see is for onboard training. But it also gives you the flexibility that you can actually train in the local office. So it means you don't have to travel to a simulator facility. You can train where it basically suits your schedule. So really it's a flexibility and mobility aspect that I see it gives you the greatest benefits. The trend right now, as I see it, and especially being fueled also with the advances in XR technology, is that the market is really opening up. Traditionally, it's been the top-tier companies that have traditionally been endorsing simulation technology. But what we can actually do now, because we're bringing the cost price down and also make it a lot more mobile, means we can actually go wider and a lot deeper in the market.
In Washington, D.C., the traditional command center, once filled with sprawling control rooms, massive screens, and complex physical infrastructure, is being condensed into a single headset. At Headwall, operators can now access real-time video feeds, monitor mission-critical data, and make high-stakes decisions, all from anywhere, without the need for an entire physical operations room.
Headwall was started as a skunkworks project from an AV company during COVID. And what was really interesting about it is that the company was building large physical command centers and watching men in uniform get sick while trying to use the command centers. They had been familiar with Varjo and with mixed reality technology and approached me and said, like, couldn't we use mixed reality to solve this problem? we started with that idea of like, how can you access a physical command center from within virtual reality or mixed reality? So we use mixed reality as a way of like extending that capability, either like across post, across network, allowing people like chief security officers to access the command center from their houses or offices. So what we have here is a mixed reality workspace. So what you can see is that what would normally take the space of like a large video wall or an 8 monitor setup or 18 panel video wall can now be delivered in just the headset that Teja is wearing. So you can say, here's a fire alarm monitor and I want to see that here. Here's the security camera that's monitoring that room and I want to see that here. And here's a map that shows me where that fire alarm is and where that security camera is. And if you picture that situation iterated like a dozen times where I'm monitoring dozens of cameras and dozens of sensors and I need to see those things all at once, we allow you to use mixed reality to bring all of that in. And the thing that we've done that makes us a command center technology and not just a workspace technology is that we have a bunch of tools that are specifically aimed at command center operators, command center operations. And that looks like physical security, command and control, and also intelligence analysis. Teja can bring up this quad view, like we can look at different quadded security cameras and bring those in. So these are encoded video streams that are coming in off of a network. So that's very important. Like all of our information is able to be ingested in real time. What we've been able to do is optimize the performance on tactical networks and have a really ironed out flow from capture to delivery, where operators can monitor what's going on unmanned surface vessels. So that means like drone boats, unmanned aerial vehicles, and be able to basically view on a map where a vehicle is, touch where that is on the map, and then see what that vehicle sees. And so in that way, we're starting to address a lot of the problems that are coming out of certain conflict areas like in Ukraine and other things. And we're seeing military organizations look at unmanned vehicles as a way of pursuing that. And we're starting to see requirements coming out of there that we're able to address.
It's clear that XR technology has already matured enough to be relied on in various industries, but the evolution of the technology is still taking place, with breakthroughs and innovations taking place every day. In Brooklyn, engineers at OpenBCI are pushing the boundaries of XR by combining it with brain-computer interface technology. Their custom-built headbands track brain activity, heart rate, and cognitive load, giving trainers new insights into how people react, learn, and make decisions under pressure.
Our products, Galia collects data from the brain, EEG data from the scalp, muscle activity around the face, conducts your heart rate, something called EDA, electrodermal activity, which is like your body's skin and sweat response. And then it also has a couple different forms of eye tracking. So you get these like 5 or 6 different streams of physiological data, and the whole thing can be combined as this really, really tightly time-locked biosensing super tool. So this is one of our beta prototypes. It's a little earlier model, but it's still got all the same stuff. So you can see you got the Varjo on the front. This is the Arrow. And then you've got 10 EEG sensors in there. So these are the sensors that contact your scalp and collect brain activity from the skin on your scalp. So in the face pad, we've got muscle sensors and the skin sensors I was talking about, electrodermal activity. So that's your sort of sweat and skin response. And then you have to use, anyone who's done this kind of biosensing stuff will understand you use these ear clips for, ground and reference. But we've also added on a PPG sensor, like the ones in like Apple Watches and the kind of like light-based pulse monitoring. So you can collect heart rate data from this clip that goes on your ear. And all that comes together with Varjo's eye tracking and some eye tracking data we get from the electrical measurements in the face pad to create, this high-powered biosensing VR combo device.
So you have this BCI tech and you're connecting it to a headset. What's the point in connecting a VR headset and BCI tech?
VR and AR are really good experiment platforms because you can put people in very realistic settings while also controlling it like you would in a laboratory. So it's pretty natural. We saw our customers wanting to combine data from the eyes, the brain, the skin, muscles, heart data, combine that in these VR experiments they were doing and sort of tightly time lock it all together and monitor it in real time. So you see people doing, user experience testing in automobiles or airplanes, and then monitoring people's eye movements and their heart rates and different, reactions to the content. We've done racing simulators, we've done flight simulators, we've done monitoring people's reactions to sort of big crowds in different environments.
So users are getting some sort of visual stimuli through the headset, and then that's changing or affecting the data that's recorded through the BCI tech.
So when people are using Gallia, there's usually, the person inside the headset is doing some kind of experiment or experience or user test or training activity. So they're just seeing the regular VR graphics that you might see in any other Varjo headset. What Gallia adds is the ability to record all of the reactions and responses from their body in real time. So there's usually a second person, kind of the experiment, lead, monitoring on a second screen their body's responses, their eye movements, their brain activity. You can use that data both to analyze how you react to educational content, to gaming content, to entertainment, and quantify mental states like stress and attention and emotional states. And then you can also use the same types of data to create hands-free control schemes. So being able to replace the mouse and keyboard with eye movements and subtle gestures and even imagined commands.
Right, so right now, Joe's in the Gallia headset, and on the left here you can see our Gallia GUI to visualize all the raw data streaming out from the headset.
It's one of the most common ways that we can just check that it works is pretty much everyone, not everyone, but most people, if you close your eyes, you should see the alpha frequencies of your brain waves really rise.
There's a big spike, and you can also see the green bar is raising. So the sound and light are reflected on the colors of the power bands. So if Joe closes his eyes, you'll hear a specific frequency and a sound indicating to him that he's getting into the alpha state. So you can see the color and sound are changing.
I think where we are today, the truly interesting stuff is happening in the automotive space, in the aerospace world, in the research labs, both government and academic.
Over the last 4 years, HMD technology has grown and the mixed reality has blossomed, and the technical advances have been amazing.
Well, much like CAD when it first appeared in the 70s and 80s, I think XR is going to transform our industry fundamentally.
If we can save even 1 or 2 lives with some of the software and technology that we're putting together here, from my perspective, our job's complete.
It can be a catalyst to ensure that we improve safety of life at sea by giving many, many more seafarers the ability to do much more simulation training in the future.
Once people put on the headset and they understand that you could potentially save millions of dollars in mistakes or conflicts because you're detecting them early on, that's huge.
It's palpable enough that it really adds value, and enough that we at Headwall have decided that we won't deploy on anything that doesn't have mixed reality.
This is going to transform software, education, entertainment, gaming, and in the healthcare space, you'll see the same thing.
We're in a world where we're trying to increase the number of medical staff, medical capability, particularly in defense, but also across health and other sectors. And it's almost impossible with the resources that we have to adequately do that through real-world experience or live training. That's where simulation comes in.
So, was VR really a failure? Or did we just misunderstand where it was always meant to be? The grand vision of the metaverse never materialized in the way it was promised. But while the world moved on, XR never disappeared. It simply found its place, quietly transforming industries that demand precision, safety, and efficiency. For fighter pilots, surgeons, engineers, and military operators, XR isn't a gimmick. It's an essential tool. Whilst the public may have lost interest, professionals never stopped using VR. Because for them, it was never about replacing reality, but training for it.